Hello, physics students. I am Mr. Williams, and today we're going to discuss Newton's second law of motion. By the end of this lecture, you can calculate the net force acting on an object, the mass of an object, or the object's acceleration using Newton's second law of motion equation. So let's begin with an exercise. Would it take more effort to throw a paper wad or a basketball? Newton's second law of motion describes how the net force on an object, its mass, and its acceleration are related. Remember that net force is when you add up all of the forces on an object, whatever is left over is the net force. So we wouldn't consider gravity in the net force of an object if we are just rolling something across a flat surface. If we were trying to determine the force on an object that was being thrown straight into the air, well, gravity would be pushing down on it and slowing it down and eventually reversing its direction back to the ground. At that point, we would consider it. But we'll make it clear in our examples which force we are going to use in any of the calculations. Think about throwing a ball in two different ways, a hard throw versus a soft throw. Obviously, if you throw a ball very hard, you're using more force than if you are throwing it very softly. When you throw a ball with a large amount of force, it has a greater change in velocity in a shorter period of time. That's acceleration. Therefore, the greater force that is applied to a ball, the greater the acceleration. So let's think about another example. A baseball and a bowling ball. Let's think about mass and acceleration. Think about throwing a baseball and a bowling ball with the same amount of force. The baseball has much less mass than the bowling ball. Even though both balls have the same amount of net force pushing on them, the bowling ball has less velocity than the baseball. If it takes the same amount of time to throw both balls, the acceleration of the bowling ball is less than the baseball's acceleration. Makes a lot of sense. If you were going to throw a baseball as hard as you can, it's going to go much faster and it's going to accelerate at a higher rate than if you were throwing a bowling ball. Okay, this means the acceleration of an object depends on its mass as well as the net force on it. Net force, mass, and acceleration are related. So Newton's second law of motion states that the acceleration of an object is in the same direction as the net force on the object. That makes sense. If you push forward on a refrigerator, you would expect it to move forward. Now, the acceleration, mass, or force of an object can be calculated by the equation F net equals ma. And very famously, it's F equals ma. Force is equal to the mass times the acceleration. A is equal to the acceleration in meters per second squared, most commonly used. The force, or the net force, would be in newtons, and the mass would be in kilograms. We use meters per second squared and kilograms because that helps us get the unit of newtons. Because after you multiply mass times acceleration, the unit would be kilogram meters per second squared, and newtons is just an easier way to think about it. Okay? Let's view some examples. We are going to calculate the amount of force required to accelerate a 0.5 kilogram water balloon to 5 meters per second. Okay. Whenever I'm doing a calculation, I always like to write down the equation that we're using. So I'm going to write F equals m times a. Okay. And so we need to rearrange the equation to be solving for whatever it is it's asking us to calculate. Well, it's telling us to calculate the amount of force. So here we are already set up in the way we want it to. So I like to say, well, what's our mass here? Well, our mass is 0.5 kilograms. All right. What is the acceleration that we're given? Acceleration is 5 meters per second squared. And so now we're just going to solve this by doing force is equal to, let me get an eraser here. I'm going to use a different pen. I'm going to use blue just because it's a little bit of a thicker stroke. All right, so force is equal to, I'm going to do parentheses, 0.5 kilograms times 5. Okay, and so you put that into your handy dandy calculator, which you're going to need a calculator on this week's quiz. And for some of our assignments, we're going to need a calculator. All right, so you can just put 0.5 times 5. What do we get here? 2.5. So our force is going to equal 2.5. 2.5 what? Well, we're talking about force, so it's going to be 2.5 newtons. And I like to put a box around that final answer. So that's how you're going to calculate the amount of force. Okay, another common application is calculating the acceleration of something. So I'm going to begin by writing down the equation. Force equals mass times acceleration. Okay, well, we're being asked this time to determine the acceleration of the object. Well, we're not set up for acceleration, so what do we need to do? We need to divide both sides by m, and we'll get that equation. So the m cancels out, and then this equation will turn into force divided by mass is equal to acceleration. All right, easy. We're just going to have to divide. So we're just going to have to determine from the problem, what is the force? Well, what's the acceleration of a car that has a mass of 2,500 kilograms and is being pushed with a force of 100 newtons? Well, force is going to equal 100 newtons. Okay, and what's the car's mass? Okay, it tells us that it's 2,500 kilograms. All right, so now we're just going to plug and chug. Well, we're going to put 100 in for our F. All right, we're going to put 2,500 for our mass. And our acceleration is going to be 100 divided by 2,500. Okay, this isn't going to be going very fast. So we have 0.04 meters per second squared. Does that make sense? What is the acceleration of a car that has a mass of 2,500 kilograms? That's pretty heavy. It's being pushed with a force of 100 newtons. I think that makes sense because we're talking about a massive object that we are trying to push. So it makes sense that this would be a small acceleration. All right, let's try one final example. All right, so if I can zoom out a little bit here. Example 3, a football coach learned that his best player was not doing well in physics. So the coach developed a test to have the player calculate the mass of a football. He had the player throw the football at a scale that measured the force of impact in newtons. The coach recorded the acceleration of the player's throw, and it was 5 meters per second squared. Correct that. And it was 5 meters per second squared. What is the mass of the football if the player threw the ball with 10 newtons of force? Okay, so we're going to start with our original equation. Force equals mass times acceleration. Well, we have to figure out the mass of the football. So we need to rearrange the equation. Well, we need to get rid of that acceleration. So we divide both sides by acceleration. So it cancels out over here. And then on the left side, we'll have force divided by acceleration. And then I'm going to rewrite it in black right here. Force divided by acceleration is equal to the mass. Okay, so let's identify what our force is. It tells us in the problem that force is equal to 10 newtons. And what is our acceleration? Well, our acceleration is 5 meters per second squared. Okay, so we're just going to plug all this into that equation. So I'm just going to draw an arrow. And then we're going to have 10 newtons divided by 5 meters per second squared. Okay, and that should give us the mass of the football. Okay, so we have 10 divided by 5. All right, and that would give us a 2 kilogram football. I looked up how much a football weighed before I did this. That is not how much a football weighs, okay? So this is the correct math, right? It doesn't make sense if you know what the football actually weighs, but I just put in some numbers here to give us the idea. So 10 newtons divided by 5 meters per second squared would give us 2 kilograms. So this would be our final answer. Okay, now that we've done 3 examples, let's do a practice exercise. Okay. Find the amount of force required to accelerate a 200 kilogram object to 50 meters per second. So we're going to start with the equation. Force equals mass times acceleration. Okay. Well, what is the mass here? What is the acceleration? Oops. What you're going to have to do is you're going to have to find the mass from the problem, and then you're going to have to find the acceleration from the problem, and then you're going to take those two and multiply them together. Practice exercise number 2. Find the acceleration of a 25 kilogram object that has 100 newtons of force applied. So this time we're finding acceleration. So force equals mass times acceleration. Okay. Remember, you should have the algebraic skills to be able to do this. Okay. This isn't high school algebra. But if you want to get acceleration by itself, what you're going to have to do is divide mass by both sides. All right, that cancels out. And then we could rewrite the equation as force divided by mass is equal to acceleration. Okay, if you don't have that skill, make sure you get that skill. It's essential if you want to learn high school level material. All right, so we need to figure out what is the force that we were given. what is the mass that we were given? After we find that, we're just going to plug the force, put that number up there, and then we'll put our mass in right here, top to bottom by bottom, and you have the acceleration. All right, guys, this is how you apply Newton's second law of motion to determine either the force applied, the acceleration of an object, or the mass of an object. You guys can do this. Just keep on practicing. Have a nice day.